Let's look at some chapter 6 on percent problems. This problem, you're going to read it carefully. It has some mixed information. It tells you the percent of female employees, but it tells you the number of males in the company. And it's asking how many total employees, male and female, there are in the company. Make a little diagram. Notice that 60% are female, but over on this side, there are 800 males. That's mixed information, female, male, percentage, quantity. If there are 60% female, that means that there are 40% male. If we want to look at all the employees of the company, male and female, and we take 40% of it, 40% represents the males, that should equal the quantity of males, which is 1,800. Change 40% into a decimal, 0.4, divide both sides of the equation by 0.4, and the total number of employees in the company is 4,500 employees. Think about the problem. It really is, if you diagram it out, it makes a lot of sense. Let's look at another problem. Let's look at a percent application. Where we're trying to find the percent. A state has an urban population of 6 million people. The remaining population living in the rural area is 4 million. What is the total population of the state? Well, obviously, we add the urban population to the real population. 6 million plus 4 million, it gives us 10 million residents in the state. What percent of the state's population is urban? What part of all is urban? So to find the percent, we take the urban population quantity divided by the total population quantity. That's a fraction or a decimal. Convert it to a percent, we multiply by 100%. So 6 million over 10 million, which of course is 0.6. Converted to a percent, we shift the decimal point 2 places to the right. Let's look at a percent increase or decrease situation. They're both handled the same way. Between 1880 and 1890, assume the number of telephones in the country increased from 50,000 to 300,000 in round numbers. What percent of increase was this? I made a little picture. We're going from 50,000 to 300,000. The actual change is 250,000 phones. When we're figuring out the percent increase or decrease, it's the change in the value over the original, not the final value over the original, as a number of students do. So the change in value is 300,000 minus 50,000. The original value is 50,000. That gives us a calculation of 250 over 50. Converting that to a percent, that's 500%. Let's examine compound interest versus simple interest. This problem is asking for the final balance after compounding the interest to the nearest penny or cent. Let's do this for a principal of $910 with an interest rate of 3.8% for 12 years. If this were simple interest, the total amount for 12 years would be equal to the principal plus the interest. Well, the principal is originally $910. The simple interest, mistake was made. Simple interest would be 3.8% times 910 times 12 years. So I did make a mistake on this. Checking my work, the calculation down here is correct. I did leave off the 12. It should be 3.8% times 910 times 12, which would be the simple interest over 12 years added to the principal, so the total amount would be $1324.96. Let's do this problem under compound interest thinking. Let's go through the idea of compound interest. The interest at the end of the first year is found by taking 3.8% times 910, which gives us $34.58. The amount of money at the end of the first year would be the original principal, $910, plus the interest, which now gives us a total of $944.58. To calculate the interest for the second year, we take 3.8% of $944.58, the new amount, rather than the original amount, and that gives us $35.89. Notice the interest is a little bit more than the first year. To find the amount of money at the end of the second year, take that principal, $944.58, and add to it the new interest of $35.89, gives me a total of $980.47. The interest during the third year is 3.8% of this new amount of money, $980.47. That gives me an interest of $37.26. Notice the interest each year is going up a little bit. The amount of money at the end of the third year is $980.47, plus the new interest, $37.26, gives us $1,017.73. We would continuously do this for 12 years to come up with the total amount of money at the end of 12 years. A much easier process, that's the thinking, is to use this formula, and that is to take the principal, multiply by 1 plus the rate of interest, all raised to the amount of time. So the principal is $910. Parentheses 1 plus the rate of interest is 3.8%, raised to the number of years, which is 12. So what we want to do on a calculator is add these numbers together. So that's going to be 1.038. We want to raise it to the 12th power. And after we've raised it to the 12th power, we're going to multiply it by 910. The calculators give me an answer of $1,423.670986, etc. But we need to round this to the nearest penny. Nearest penny is 2 decimal places, not 1 decimal places. So the answer is $1,423.67. Notice on compound interest, we actually make more money or pay more interest than if we had simple interest. This gets much, much larger when we're dealing with, let's say, buying a home, which may go for $300,000, and you're doing it for 30 years. The difference could be many, many thousands of dollars compared to simple interest.